Okay, so VectorNav. I understand you guys make a mysterious thing called an inertial measurement unit, and this plugs into your GNSS system, and it's really important because, as we all know, you could lose GNSS or it could be jammed. Speaking very slowly, because I majored in political science, could you explain what an IMU is, why it's important, and how it fits into keeping your navigation position?
Yeah, absolutely. So an IMU, inertial measurement unit, generally consists of accelerometers that measure your acceleration and then gyroscopes that measure your angular rate. And we can use that to measure your motion at really high rates and provide you a position update much faster than what GPS is capable of. And the other advantage is when we combine those two pieces of information between the GPS and the IMU, we can give you something that GPS alone can't give you, which is your orientation or your attitude, your yaw, pitch, and roll. And so that's exactly. So that's a really critical piece to it. And then, of course, if you do have issues with GPS, if it's not available for some reason, then the IMU, the integration of those accelerometers, position is the double integral of acceleration, if you remember high school physics, and so we can use that to maintain a position and velocity estimate even after we lose GPS.
So how long does an average IMU retain that position? Doesn't it decay over time, or how does that work?
It does, yeah. Because you're doing a double integral, the position accuracy degrades with time squared, so it gets really bad really fast.
Okay. Again, political science
sorry,
major, so that's bad, right?
Yeah, so if you take the time, if you double the amount of time, you're going to quadruple the amount of error is what's going to happen as you integrate the IMU. And so there's different grades of IMU. You've got industrial grade IMUs, you've got tactical grade IMUs, and then all the way up to navigation grade IMUs, which kind of what historically the military has used and can keep your position for an hour or more.
Oh wow!
But that's going to be really big and really expensive, and not a great option for an autonomous system where size, weight, and power swap is really key. To give a sense of it, our industrial grade sensors are going to be on the order of 20 to 30 meters of error after about a minute. And again, if you double that up to a couple minutes, you're going to be at 80 to 100 meters type error. So it can work for seconds, usually tens of seconds, maybe. It's great.
So what would an application be?
Yeah, so it's great for a lot of applications where maybe you're driving through a city and you've got some blockages from the buildings nearby you, what we call the urban canyon.
I'll hate that. So
exactly.
You're using Waze or whatever, and then you go between two buildings, and
you skip to a different road.
Gotcha,
exactly.
Gotcha.
Right, we can fix that. Or you're a bridge sitting over an overpass, maybe driving under trees. Situations where GPS is a little bit degraded, but you're not losing it for an extended period of time. Then the tactical grade sensors that we offer, we focus in terms of what we build into our sensors. They're all what we call MEMS IMUs. And so these are micro electromechanical systems, very, very small, very, very rugged.
It's kind of what my phone has.
Exactly.
Okay.
It's the technology that your phone uses.
So it tells whether you're flipped up or down.
That's exactly right. Gotcha. That's exactly right. And so we use these tactical grade MEMS IMUs, and so that can get you to about 5 meters in about a minute type of navigation accuracy when you lose GPS. So now we can handle GPS outages for a couple minutes maybe.
Okay.
And so it works better if you are experiencing those kinds of outages, right? If you're flying through a jammed region or something like that, right?
Okay.
And so, but then to go even beyond that, you've got to get to higher and higher performance IMUs. And so the way VectorNav has been dealing with that and addressing that is that there are a lot of great IMU manufacturers out there that do much higher end systems, some things called fiber optic gyros and things like that. And so we've built our systems to be able to use data from those higher end IMUs into our navigation solution directly.
So a fiber optic would be used by a military system.
Fiber optic could be used by a military system for sure, and that can extend how long you can go without GPS and how accurate it can be, and we can use that information for those integrals.
Okay, so essentially an IMU is something that allows you to keep your position for X amount of time depending on the quality of it, and sounds like you're somewhat neutral on the type of IMU. You've got your own that you can provide that's largely MEM-based, but you could plug in a laser ring gyro.
Yeah, that's something, exactly. Yeah, that's something that we've been really working on over the last few years, is expanding the types of IMUs and GNSS receivers that we can support. A lot of what VectorNav brings to the table is our navigation filtering expertise, and we found that our customers want to use our navigation solution. They just needed a higher performance sensor than what we could fit into our tiny little boxes, and so we've done that by creating various pieces of software that let us do that.
Okay, well that sounds great. So what differentiates your product from everybody else? Why should I buy VectorNav?
Why should you buy VectorNav? That's a great question. I think the first thing that people notice about VectorNav is our small swap, our size, weight, and power.
Okay, the most expensive thing in aviation. Okay,
exactly,
gotcha.
exactly. So that's the first thing most people notice. You're not going to get better performance in a smaller form factor than what we can provide. But I think what really keeps our customers is our commitment to providing navigation solutions and not just sensors. We're not providing you with just an IMU and with some angular rates and accelerations. We're giving you a yaw pitch roll. We're giving you positions and velocities. We're handling those GPS outages. We're doing that as accurately and reliably as can be done with these sensors. And we're really committed to making sure that we're providing, again, navigation solutions to our customers, which means that our support team is there to work with you and make sure that we can solve your navigation problems so that our customers can focus on the things that they're experts in, right? They might be experts in building gimbals or drones or robots, right? Lets them focus on the things that they're best at while we handle the navigation side of it for them.
Okay. How would you characterize your market? Are you mainly commercial? Are you mainly consumer? Are you mainly military?
So it's all business to business, but it's definitely a big mix between commercial and military.
Yeah, I guess so. And your end user, what does that end up?
I'm sorry?
Your end user.
Yeah, that's right. Yeah, so we, so it's everything from commercial drones to military ones, but really anything that moves and needs to know where it's at or where it's pointed, we've probably done it. We've done everything from marine survey to gimbaled camera systems to satellite communication terminals. So we have quite a lot of a show like this that highlights all sorts of autonomous systems. It's a great show for us. We have a huge number of customers, partners, suppliers at this show. It's a great opportunity to spend some time with them.
Yeah, so I'm Air Force, so we've been watching the war in Ukraine very, very closely. There's a tremendous amount of GNSS jamming going on there.
Yeah, that's right.
I mean, if you were with the Ukrainian Army or Air Force and you had to come up with a solution for, say, like a Group 1 UAS, do you have something there, and do you have something that can really operate in a real heavy GPS jamming environment?
Yeah, so it's interesting. A lot of it depends on on your ConOps, right? Your concept of operations, and what you're going to be dealing with. In some situations, you're just trying to get through a jammed zone, right? Where maybe some middle ground is being jammed, but each side's not jamming themselves, and so you've got some room to break. You just need to be able to fly through it. In other circumstances, you just need a more robust GNSS receiver, right? So we do have, in addition to being able to take in external IMU data, we can also take in external GS or GNSS data. So we can take in what are known as SASM or M-code receivers, which are the military-grade receivers.
Yeah, explain them. What is that?
Yeah, so these are primarily anti-spoofing receivers. So spoofing is when somebody pretends to be a GPS satellite and tries to you off course. You track their signal instead of the GPS signals. And the SASM is the older technology. M-code is the newer technology that's being used today by the U.S. military. And they allow to the use of the encrypted signals on the GPS satellites so that you can't be spoofed. The M-code receivers, this new generation of technology, also does a better job of handling jamming. So jamming is when you're just flooding the airwaves with noise so that you can't hear the GPS signals in the first place. And the M-code signals are stronger. They're a little bit easier to find, pick out noise. And often those M-code receivers then get paired with an anti-jam antenna. So
what is that?
Anti-jam antenna is typically an antenna that actually has multiple antenna elements. And because it has multiple elements, it can actually figure out the direction of the signals that it's tracking. That way,
So GPS satellites in outer space, Russian jammer. Okay, all right.
Yeah. Exactly. And so you can differentiate that and avoid the jamming. So in a lot of circumstances, that's enough, right? Depending on how high you're flying or how far from the jammer you might be able to avoid the jamming altogether by pairing an M-code or SASM receiver with an anti-jam antenna, especially if you've got an IMU to keep everybody honest, and that might get you through.
Okay, so I know you guys are big into integration. Can you integrate all that technology into something that makes it dead easy for me as an OEM to just plug your product in, or do I have to do my own integration work?
Yeah, so that's something that we're still working with a number of partners on kind of developing that. There's a lot of moving pieces there, a lot of different, the antenna manufacturers, the anti-jam antenna manufacturers, there's multiple there. Some people want to use one and not the other. Quite a few GNSS manufacturers as well. We're trying to make it as simple as we can from an interfacing side of things while allowing for flexibility from the customer to pick and choose the system they're most comfortable with.
Okay, so I'm a customer, I'm coming in, I've got a Group 1 UAS that, I'm Ukrainian, I'm going to fly in there. How would I work with you? You like one of those sushi menus where you choose one from column A, one from column B? Or?
Yeah, it varies a lot depending on who we're talking to. Some people come in and say, I've already got this GPS receiver and this antenna and I want to use those, and can you face with that? And then we work through that. Others come to us and say, we've got this broad requirement to handle GPS denied navigation, what that means, and then we work with them and say, well, we've worked with these people and these people and these people. You should go talk to them. We can work with any of them and figure out a way to make this system happen. One of the nice things about the way our sensors can integrate these external GPS receivers and things is that you can start your development process with our standard products, because sometimes getting these government-controlled GPS receivers take a year or something to figure out.
Oh, that's a good point. Particularly the M-code.
Right, exactly. Supply chain issues and everything else. You can start with our commercial-grade receiver. You can do all of your integration and tests, all of our software development. All of our software is still going to work once you add in the M-code receiver, so you can test out the rest of your system. And then when you got that M-code available, or once you get to that stage in development where you need to prove that, you can incorporate that M-code. Nothing changes from the integrator standpoint. They're still just talking to our sensor, and then we can move on from there.
I hear a lot about vision systems for true GPS denied territories. Do you have?
That's right.
Could I integrate a vision system? Where you got your sensors that are looking for a road junction. That's where that road junction is.
That's right.
Does it work, or did I make that up?
That we don't have that just yet. We're working on that with a number of customers. We're looking at things like vision for sure. We're looking at things like LEO satellites and signals of opportunity.
Oh yeah, I guess Air Force is working on that too.
That's right.
Yeah.
LiDAR too. There's a lot of opportunities there. We're taking our time to make sure that whatever we come out with is going to be reliable in a wide range of circumstances, because kind of one of the worst things we can do is tell you we know where we are when we don't. And so we're making sure that we've got systems and partners that we can trust and that are going to give us a great, reliable solution.
Okay, so we're starting to get the hook here.
Yeah.
Was there anything we missed? And I got to apologize, I kind of drove you off a cliff into the military side, and we didn't talk enough about the commercial side, but what did we miss about VectorNav?
No, I think we did a great job covering it. I would just say, come talk to us. So one of the things that we've done a lot of work in is a lot of higher-end UAV performance. So things like VTOL systems and catapult launch systems and things like that.
Oh, okay.
So a lot of these more aggressive aerial maneuvers options.
So you're going to survive the shock.
We're going to survive the shock. That's one of the great things about MEM sensors. And our algorithms are designed to handle all that.
So. Oh, wow, that's fantastic. All right, one final question.
Yeah.
Will you or will you not sell to the University of Texas at Austin, or do you have standards here? Don't answer that question. All right, VectorNav, folks. Great talking.
Thank you so much.
Learned a lot.
Appreciate it.